Thanks everybody for joining in this afternoon. This is the first of the Lessons to be Learned series for 2022. And joining here today, we have Nick Rogers. Nick's a geomorphologist and geotechnical specialist. He's just retired from Tonkin and Taylor. While Nick was at Tonkin and Taylor, he was a director there for 20 odd years. And when he retired in 2021, he was a technical director. He was one of the first on the scene, or one of the first professionals on the scene in Abbotsford in 1979, and is a natural disaster assessment specialist. And so very few people that are better qualified to discuss the Abbotsford slip with us today. When you have any questions and answers, then please do put them into the Q&A box, and we will address them all at the end of the presentation. If it starts to run over a little bit, then we will address any answered questions and send them out with the recording. Thank you very much, and over to you, Nick.
Well, kia ora everybody, and thank you very much, Martin. Also, these case study seminars don't happen by themselves, and a lot of work goes on behind the scenes. And I'd like to thank in particular Bernadette Ramos, who put this together in the terms of the new Engineering New Zealand presentation format. And she's actually helping behind the scenes and actually still is sitting behind our screens today. So thank you very much, Bernadette. 2 years ago, Nathan McDougall and I presented to many of you the results of a critical analysis of the Shrinksville test for expansive soils. It doesn't work, it's fatally flawed. But the point we were making was that many of us actually rely on that Shrinksville test for designing or choosing residential building floor slabs. The issue there is building damage from soils expanding with flooding and shrinking with drought are basically things that eventually get cheated back to the engineering professions. Most of us did not know that the SLS requirement for Shrinksville is to prevent damage under a 500-year return period drought. And I guess what we didn't probably emphasize sufficiently is that with climate change, some areas of New Zealand are going to be much more susceptible to drought, so that that 500-year return period drought is going to be occurring much more frequently. However, drought and expansive soils are thought basically as Northland and Auckland problems. And when we tried to get MB, get the attention of MB, Wellington seemed to share little or no interest. So last year, I gladly accepted an invitation to talk about the lessons from a landslide that occurred down the bottom of the South Island. And that occurred from a chance meeting between Hugh Cowan and Martin Pratchett. Hugh Cowan, many of you will know, was the research head of the Earthquake Commission. And it just so happened that he had recently read a paper that Don Taylor and I had put together, and that was published in New Zealand Engineering in 1986. So those of you who are putting papers in journals, don't despair if at first people don't come back to you. It might take 36 years. So unlike our previous presentation, you'll be glad to know that this one doesn't contain any formulae or equations. So without further ado, we'll skip through things. So basically, I'll be talking for about half an hour, and then we'll have a Q&A after that. And hopefully I'll generate quite a lot of discussion, because with these case study lessons learned, that's really the intent. So Abbotsford, unlike many case studies, this is not the engineering professional making a mistake. So it's not an actual mistake that we made that we are sharing to learn from it. I could talk for probably a week on the mistakes that I have made over the last 42 years as a geotechnical professional. But the Abbotsford landslip disaster and the commission inquiry that followed changed the way society and councils account for losses arising from natural disasters, in particular landslides. And councils have actually transferred the liability for basically geohazards to geotechnical engineers and engineering geologists. And this presents, I believe, an issue for us, because natural systems are complex and dynamic, and they're very difficult to analyze successfully. So many engineers with structural engineering training claim geotechnical competence, and that's fine. But 42 years on after Abbotsford, we're still building on actually or potentially unstable land, which demonstrates that a key lesson from Abbotsford has actually not been learned. So it just happened that one early afternoon in early August 1979, I actually was sent down to Abbotsford, not to actually look at the landslide per se. We had a whole team in Wellington of Brickell Moss, now Oricon at the time, actually investigating and analysing what was happening, which they didn't unfortunately quite crack. But I had actually gone down to look to see whether the local authority could be maybe held accountable for the damage that was arising to the residential buildings actually built on that land. So I was actually looking to see, could the Earthquake Commission hold the local authority to account for the damage that was actually occurring? What I didn't know, of course, because we've been looking at this landslide for a while, was that in the morning, the nice flat grassy area, which had these nice ripples and rolls in the grass at the toe of the landslide, would be 20 feet, 80 meters closer to the sky. So late on the evening of the 8th of August, a very large landslide suddenly occurred in the urban area of Green Island Borough. The landslide had been moving for months, and the feeling was that because it was just slowly moving, it would continue to slowly move, and eventually it would sort of arrest itself when it hit the other side of the valley. That, of course, didn't occur. But other landslides that we are aware of, things like the West Taihape landslide with 206 houses on it, are actually still actively moving, but are unlikely to actually accelerate like this one did. 69 houses actually fell down into the grabens that were multiple grabens across this block slide, largely at the head of the slide. No one died, but come daybreak, I was one of the first on the scene with Errol Chave, who was the engineer for the Ministry of Works, and Ian McKellar, who was then the geologist with Geological Survey, DSIR, and we were lucky to have a helicopter at our disposal, and we took to the air and had a look down at this extraordinary scene below. Of course, one thing that Errol, being a structural engineer, quite quickly noted was that all these houses were in a terrible disarray down in these landslide scarps, but all the roofs seemed to be absolutely fine. And so Errol said that clearly these roofs have been over-designed. Now, just a bit of background is that when we look at natural disaster insurance in New Zealand, it actually started off in 1941 with the War Damage Act. This was what had occurred in Britain that was being bombed by the German alliances, and we followed suit because we thought that there was a good chance that we too would be invaded by probably not the Germans, but possibly the Japanese, who had joined the war effort. And so that basically kept on going. But then when it became evident that in fact we probably weren't going to use all the money that was piling into this fund, the government added earthquake into the mix, and that sort of kept on going for a while. The funds still kept on accumulating because a lot of the big landslides had actually occurred from 28 to 42, and come sort of 40, 44 on, very little large scale damage was actually occurring. So they added earthquake, and they added volcanic eruption and some other perils. But it wasn't until 1970 that Landslip was added to the list of perils that the government insurance scheme actually covered. At the same time, the Local Government Act, which then looked after basically subdivision and building consents, they amended the Act to make it very difficult for councils to allow subdivision or building on land subject to landslip, amongst other perils. And later amendments came in which made it almost impossible for councils to allow subdivision and building on land, not only that was subject to, but likely to be subject to land slippage. And as we documented in that paper I referred to earlier that was published in NZ Engineering, councils found this a bit of a pill to swallow, because what basically happened was that councils could no longer issue a building consent for a lot that they had previously issued subdivision consent. And of course, people got pretty upset about that and started to sue councils throughout New Zealand. If we look at the Commission of Inquiry, whereas I'd gone down to see whether the council could be held accountable for allowing development on this then landslide, the Commission of Inquiry effectively took that over, and it was because of the sheer scale of the landslide, and the public really demanded to know how this could happen in a residential area. So eventually the Commission didn't attribute any blame for the landslide, and I can't publish it because of copyright, but I remember the cartoon, I think it was Bromhead, which basically have all the commissioners sitting around the table saying, that's the way the cookie crumbles. Another one was suggesting, well, maybe we should say that's the way the grapefruit squirts. And I guess what this, reinforced was that generally commissions of inquiry don't actually end up blaming anybody. And I guess we look at the Royal Commission into the Christchurch earthquakes as well. But what the Commission of Inquiry did result in was that they had a lot of recommendations and government actually acted on a lot of those, and they acted on them quite quickly. At the time of Abbotsford, buildings were insured but not land. And as a result of the Commission of Inquiry, land cover was introduced into the Natural Disaster Insurance Scheme, the Earthquake and War Damage Commission Act as it was then, in 1984. And at the time of the disaster, you could not actually prevent damage from occurring to a building. You couldn't actually act. So everyone had been watching these cracks occurring in the ground, and the cracks were getting bigger, but there was no ability to actually pick up a house and take it off the landslide at that stage. So another result of those recommendations, which was brought in, was the aspect of imminent loss provisions, which added to the Earthquake Commission Act. So natural disaster damage now includes damage that is likely to occur if no action is taken in the next 12 months. So you can actually have a crystal ball and look ahead, and you can now actually act before natural disaster occurs, providing the cost of acting is going to be less than the cost of the damage. The Commission also recommended that there be no changes at all to the Local Government Act and the amendments which actually held councils responsible. We do not recommend any change the issue of liability to local councils in respect of the control of subdivision development and building construction. However, as we found out, political pressure basically takes over from good intentions, and on 23rd of October, they issued an amendment or enacted an amendment to the Local Government Act, which gave the local authority the power to issue building consents on land that was subject to instability and not be under any civil liability at all. So it basically gave local authorities a free pass. And this amendment to overturn the recommendations of the Commission went unnoticed, and largely it was because of the divisive Springbok tour that was occurring at the same time that this was actually introduced and debated in the House. And just for the record, unlike John Key, I do remember what I was doing at the time of the Springbok tour, and I was on the side of the protesters, and I joined Patu Squad in Auckland to try and stop the test occurring in Auckland, but that was a while ago. Building on unstable land, if we look at the House debate at the time, David Kay quite correctly pointed out that only 2 years prior, the House was persuaded that it should be difficult, if not impossible, to issue building consents on land that might be subject to slippage. And he asked, can the Minister explain why this particular formula was proposed? Why was it appropriate and whether local authorities had approved it? And Peter Wilkinson, the national member, responded that everyone appreciates the need for power to control building permits to avert further strategies. But there is clearly a need for flexibility to avoid the opposite position, where progress in an area is quite unreasonably held up because of the refusal of building permits. This is 1981. He went on, because of the alleged instability of the district, severe building restrictions have resulted in total restriction have been applied by council. As a result, values have been severely and adversely affected, and this has added considerable distress to local residents, as it would. As a result, development in the area has been stifled, as is confidence. He thanked the Minister for listening to and giving justice to a small group of his constituents. So this amendment was carried through to the new Building Act in 1981 with Section 36.2, and those of you who look at titles will see often Section 36.2 notices on titles, and it's carried through today with Section 72 of the Building Act 2004. So although this lets councils off the hook, such consented buildings may not be insured for natural disaster damage. The Earthquake Commission regularly turns down claims for natural disaster damage where there is a notice on the title, and they can do this under Schedule 3 of their Act. And if you can't get insurance, it's very difficult to actually also obtain mortgage finance. Therefore, there's significant pressure to obtain professional opinions that the land is not subject to instability nor likely to be so. And so councils became responsible for assessing landslide disaster risk. they pass this liability on to engineering geologists and geotechnical engineers, such that most councils now require CPENG or CPENG Geo to sign off on land stability assessments. But unfortunately, many engineering geologists and geotechnical engineers have not learned the lessons of Abbotsford. And many structural engineers are also stating geotechnical as one of their core competencies, and they're included under geotechnical in the Engineering New Zealand Register. So many geotechnical professionals and structural engineers, they use assumed soil and rock parameters and undertake simplified stability analyses, which inevitably show that land has adequate factors of safety, even under extreme conditions. Now, if we look at Abbotsford, that was a first-time failure. It had not failed before. So if you looked at the landscape, you wouldn't see that it was necessarily unstable. But like many hill slopes in New Zealand, it was only marginally unstable. The Commission of Inquiry called it geologically unstable. So it essentially had no safety margin and needed only a slight increase in driving forces or reduction in resisting forces to fail. It's a commonly held misconception that steep slopes are less stable than moderate slopes, irrespective of the geology. And the reality is that many hill slopes in New Zealand are essentially threshold slopes. That is, they're just stable at the slope angle they currently are at. They've basically got to a situation where they're quite happy being where they are. So moderate slopes may have exactly the same factor of safety, if you like, as steep slopes. Marginally stable slopes, of course, are very vulnerable to any modifications, such as cutting or filling. And the conclusion to Abbotsford was most probably triggered by removal of tow support, which was required for some motorway construction. Now, since 1978, but especially since Abbotsford, geotechnical competency has been an issue for councils. Some councils have their own little register of approved geoprofessionals, but most councils rely on Engineering New Zealand to monitor the competency of their members. So MEDI requiring CPENG or CPENG Geo to sign off on the, I guess, understanding that the competency has been demonstrated. So where does this actually take us to? Now, in 2020, Richard Phillips, Senior Engineering Geologist for Tonkin & Taylor, assisted the Rotorua Council by writing the draft updates into the earthquake and geotechnical requirements section of the Waikato LAS Regional Infrastructure technical specifications. Now, I'm not sure whether many of you know, but the LAS, which is the Local Authority Shared Services Limited, is actually a collaboration with 8 councils, although it could even be 12 now, under the Waikato Building Consent Group. And the whole idea of this collaboration is to get consistency around the issuing of subdivision consents and building consents in that now wider area. Now, I reviewed that excellent piece of work because I was the project director for that, which set out the geotechnical qualifications for assessing land development issues. And if you aren't aware of that, it's worth going to the particular website. And if you look at Collab Solutions website, you'll actually see that explained quite well. And what Richard really was espousing was that even low risk areas still need a geotechnical assessment. So independently at the same time, Martin was assisting the structural engineering profession with preparing a flowchart, which was to assist structural engineers decide when it's necessary to engage a geotechnical professional. Now, the reason for the flowchart was there have been several recent instances where structural engineers were seen to be acting outside the bounds of competence when undertaking geotechnical work. So the flowchart was designed almost like a checklist to help engineers, BCAs, and others understand when specialized geotechnical engineering was likely to be required. So it was just a tool. It was intended just to start a conversation, and Engineering New Zealand emphasizes this document as only a thing when additional information or expertise may be required. But of course, like any flowchart or checklist, they are invariably used and basically as a pro forma in terms of deciding what to do. So that chart could vary from region to region, but basically it was just one chart for all. And so the idea was that that was actually a tool to decide when do you need a geotechnical professional. But if we look at that, geotechnical expertise is a specialist discipline. You have structural engineers, electrical engineers, mechanical engineers, and civil engineers. And geotechnical expertise is really a subdiscipline of civil engineering in the wider sense of the term. And there is no such thing as a non-specialized geotechnical engineer or engineering geologist. Geotechnical expertise is required any time that a building requires support for the ground or is required to support the ground. So geotechnical expertise is required any time natural ground is modified from its natural state. And this is any time ground is excavated and placed as filter support structures as well. Richard and Martin shared each other's ideas, and there was correspondence there. As a result of that, the Geotechnical Society actually changed some of these things, but generally these actually sort of remain. So Richard considered that, sure, you don't need a geotechnical engineer everywhere, and geotechnical engineers also don't want to get involved in areas where they can't actually add real value, because that's the rationale for being in business. However, Richard felt that the simplicity of the flowchart was attractive. He considered that some of the parameters actually needed geotechnical input. And his experience on a number of sites with poor ground conditions that have led to some of the significant engineering failures that we as TNT have seen could have passed each of the steps on the chart. And that's the current chart, not the chart that he was looking at initially. Richard considered that to reasonably answer several of the steps would require geotechnical specialist knowledge, in some cases requiring deep investigations to aid that judgment. And he gave several examples. I haven't provided all those examples, but can at a later stage. But to reliably answer questions such as, is the site good ground? Is the liquefaction risk greater than low? Is the water table less than 4 meters? And are there peat or expansive soils present? Each would require input from a geotechnical specialist aided by deep investigations. Even geotechnical specialists often fail to correctly identify these. As new developments are forced onto more marginal ground conditions, which have been avoided in the past, these ground issues are ever more prevalent. And of course, as we know, with climate change, we are going to have more severe and more regular droughts and more severe and more regular flood events. And I guess we're all monitoring the situation in Westport right now as an example of that. So what Richard was saying was that structural engineers, that's a gross exaggeration, but many structural engineers do not have the technical competence to answer the questions set out in the flowchart to determine whether a geotechnical professional is required. The key lesson from Abbotsford is that before you actually put structures on land anywhere, you need to be able to understand how the landforms have developed, which is a basically geomorphic understanding, how they basically have been made up, and what processes have been involved in their making, which is the area of soil mechanics. This requires geotechnical expertise. Only then do you decide if the land is suitable. The flowchart is on the Engineering New Zealand website, and Richard's concern remain there that he basically provided earlier. So the lessons from Abbotsford was that was a first-time failure on the site. But if you looked a bit wider, an almost identical failure had actually occurred in the past. There was a mini Abbotsford, basically, which then became incorporated by the larger Abbotsford, and that was occupied by a sun club. Nudists determined to rebuild, the Evening Post reported, which I guess is an interesting image. But the key lesson from Abbotsford is that if you don't understand the wider geological and geomorphological context of a site, then no amount of computer analysis is going to determine whether the land is suitable for residential development. And I believe that this lesson has not been learned because we continue to build on land that is or is likely to be subject to land slippage. So, having sort of first given a report to a joint presentation to a joint meeting of the Structural and Geotechnical Group in Auckland in 1982, the publication of the Engineering New Zealand article in 1986, and where we are today, things I believe are not getting better, but I believe they're actually getting worse. And so we believe that the lessons from Abbotsford have actually not been learned. And this case study I've dedicated to the memory of Richard, who was a friend and colleague, expert engineering geologist, absolute loss to the geoengineering community in New Zealand. And he died while climbing Mount Taranaki on the night of 4th of May, 2020, because he had an important meeting the next day, and climbing at night was the only option, but it all ended tragically. But thank you very much for your time at the moment, and hopefully that has stimulated some discussions for you. Thank you.
And so at the moment, we only have one question, actually, and that is there a different framework for slope stability risk near roads or near roads versus residential areas? Which I think comes back to about the 4th or 5th slide you had on there.
Yes, and I guess the answer is that there shouldn't necessarily be, but NZTA use the ARL method, which has come across from Australia, to look at risk to road users, whereas we haven't really adopted that as a tool for used in the residential area. So, but basically, your analyses should be the same, irrespective of whether you're designing for a road or a subdivision or an individual property owner or anything else for that matter. So, yep.
Another one from Richard, and it says, which soil rock investigation methods, i.e. CPT, boreholes, test pits, should be undertaken when for assessing a slope stability issue, such as this example? Was any testing done?
I guess, yes. Basic core drilling, where you are coring continuously, so you don't lose any of the materials, is the right way to investigate landslides. And of course, you then want to look to see, in this case, an active landslide, just where it is shearing. But of course, what they couldn't find was this 20 mil thick montmorillonite rich layer of clay, which this very low angle block slide was actually sliding on. And it was only after the event they actually determined that, but you wouldn't have got that with the CPT. Core drilling is still the appropriate method of investigating landslides or ground conditions where you think that landslides may occur, and then look at the materials you've got and undertake the appropriate testing based on whatever you happen to find. Okay,
and next one from Stephen. You mentioned in passing that the Abbotsford slip was caused by a road cutting affecting the toe. So can you please expand on that?
Yeah, sure. No, it wasn't a road cutting. The material was removed. I think it was Patterson's quarry. Part of the toe was used for some road construction. So it wasn't actually truncated by a road per se. There are two landslides, there's East Abbotsford and West Abbotsford, and I think one was triggered in terms of the motorway construction, but this was just a borrow pit which was used to actually take material to source, for motorway construction. It wasn't actually in the way of the motorway at the time.
Great, and more of a comment than a question from Mike Trigger, saying that he's been seeing a lot of subdivisions lately that were fills, poorly controlled, stability assessment, qualitative or quantitative, has been undertaken. And David says,
yeah, we see a lot of it too.
Would you support a more relaxed approach in existing developed areas, i.e. for extensions and garages, than for new subdivisions?
Yeah, I think there is certainly a case, because they've looked at, I guess, how you take that through for building consents, and those have been relaxed considerably to just stop the people just doing minor additions and renovations of their properties. And I think that's probably true. It doesn't mean you can't get unstuck. And what we see a lot of at the moment is that people will actually excavate underneath their house to actually create more usable area. For example, another bedroom that maybe they can let out on Airbnb or something. And we are seeing a lot of problems arising from people jacking up their houses, putting it on pretty shoddy supports, and then undertaking excavations which fail. So councillors in Auckland here is forever chasing those sorts of activities. And as I say, anytime you cut into a slope, you should actually get someone to look at that first, because although that slope might appear absolutely fine behind that small cut, it may be marginally stable, and you won't know until it actually falls in on you.
I did actually see a similar thing when working as an engineer down in Wellington here, and it was genuinely terrifying.
It is. It terrifies us.
It really was. And the next one was, could you expand on how engineering geologists' assessment is getting worse, and what do we need to change, in your opinion?
I think when we produced the report in 1986 in Engineering New Zealand, we use the phrases greedy developers, gutless local authorities, and gullible engineers, but you could almost transpose all of those adjectives on all of those nouns. And I guess I think a lot of people are under pressure to not do sufficient investigation. And I think that is what's coming. And I think a lot of us don't appreciate the risks that we are putting ourselves and our companies in when we try and assist developers, individuals, corporations achieve their objectives.
One coming back is it's the same old question. How do we get clients to recognise the importance of ground investigation and appropriate geotechnical assessment? Little chip in from me here before we get going. That was actually the general intent of the flowchart that we've put out, was so that at the very beginning, clients and so on would have at least an idea that a geotech would need to be brought on board, and there would be less discussions and pressures put onto engineers later on, is the general intent.
Yep.
To stimulate those discussions and get a geotech on board. What about you, Nick?
Look, I think that's very true. I guess the problem is that the developer will also pick up that flowchart and take it to a structural engineer and say, look, this cut's only 2.5 meters. This map here says that the liquefaction risk is low. But in fact, what we know is from recent examples is that both of those can result in unbelievably bad outcomes. So I guess it's it's just that waiting, isn't it? And the balance. We need to.
What we tried to do with that flowchart is to address. We came to the realization with the Geotechnical Society that and the structural engineers is that we're never ever going to capture everything. It's almost impossible unless we were going to develop something for each BCA and each region inside New Zealand.
Yep.
And from speaking to engineers throughout New Zealand, even if we're working within the bounds of a single BCA, then different areas need different parts. And so the general consensus was that to capture, 80% of it, if we could solve 80% of those problems, then we were doing pretty well. And I think we've done that.
Yeah, no, I think that's a fair comment, Martin. And I think if we look at the, I guess, geotechnical work that's done, particularly in the UK, and a lot of our very good geotechnical engineers and engineering geologists actually are found come out of the UK, where I guess you've had the rigor through Imperial College, I guess, in particular, of the need to understand the ground. And so if you look at investigations in the UK, even though a lot of the material is pretty similar, for example, London clay is pretty extensive, you'll find investigations are much more thorough and analysis and testing is much more thorough than is generally still done in New Zealand. So I think we're still not there in terms of really looking at this to the extent it should. And I think we are just, I guess, undervaluing, I think, the need. And I don't mean us as a profession, I think the whole development industry undervalues, I think, the expertise that is available to do a proper job as against a half job.
Can't really argue with any of that. And the next question that we have is there a case for much tighter subdivision approvals, or has the recent urban development NPS trump slope stability aspects? Sorry, I didn't really understand most of that. But
yeah, no, I think there is. You should never allow a subdivision lot to be created which has a medium risk of basically causing damage to a property or people that subsequently use that particular piece of land. And what we see is that a lot of land is still being subdivided because we're moving into more marginal areas at the same time that climate is changing. And I think we're working towards the perfect storm where we're actually going to see more residential buildings becoming damaged and more people dying as a result than we have in the past. And that just shouldn't be occurring. So yes, I don't believe it's going to be solved, but there are, I guess, a lot of good ideas out there in terms of how we move forward. So certainly keeping an ear to that, but you would have thought that actually the legislation that was there should have been able to work, but it clearly doesn't. And so we still need to, I think, do we need more legislation, or do we need more industry tightening? How do we actually do that? You know, we look outside, but actually we still need to look at ourselves, I think, pretty closely as, you know, who is the problem here? And in some cases, we're the problem.
The next one is, what's your view on where S72 provisions are suitable to be applied under the Act, i.e. what constitutes adequate provision in your view?
Yeah, I mean, we need to be clear that it was junk legislation which got rebranded as enabling people to do what they wanted to do. So it was almost like a civil rights and a human rights issue. And that's how it was recast. But it was actually so not what the Commission of Inquiry into the Abbotsford Landslip disaster actually wanted for New Zealand. And I mean, Professor John McCraw, who was my professor at university, he was actually on that commission with Justice Gallen. And there was a lot of good thought put into basically how can we prevent land that isn't suitable for building on from being developed. And unfortunately, you know, we had then the section 641A, which became 36.2, which became 72. When is it appropriate? I mean, it's what we see still is that when disaster occurs with those notices on the titles, the damage to the individuals and sometimes the communities concerned is huge. So it's like anything, everyone's prepared to take a risk until it eventuates. But in this case, insurers, banks, councils saying, well, you took the risk, and so therefore it's your problem. But it's not quite that simple. And in many cases, that section 72 is put on by councils just purely to limit their liability, to make sure that they're scot-free. And basically that then puts it onto the owner, which I believe is not appropriate, because in many cases what happens is that you can only put it on if something is actually or likely to occur. Now, likely has been shown by determinations by MB to be about 100 years. So if you have an event that's, say, a 500-year return period event, ARI 500 years, and that wipes out your house, even though that was an extreme event and not something that was likely to occur, EQC will still generally refuse to come to the party. So there are a lot of problems at the moment that we see with properties with notices on them where either the hazard was not the hazard that was actually presented, and in some cases the hazard is not even listed on the notice of title, and the other one is that it was only for more frequent events than 100 years, and yet it's being used to make sure that everyone is still scot-free, and no one helps people when the event is a much more low frequency event. And that's just plain wrong in my view.
One question that has come through is, thank you for a great presentation. Please refer me to literature to study a little more of the geology of New Zealand. You got any good recommendations that you could, one or two?
Yes, I mean, you know, Geological Survey do a great job, and I mean, GNS Science do a great job in actually publishing geological maps, but be aware when using geological maps that often the surface lithologies, which actually, and the soils, which actually the problems are actually not shown particularly well. Some of the industrial series maps, the 1 to 25,000s, are really good. Auckland's got a whole suite of those. They're no longer being produced, but the old Soil Bureau DSIR division again produced very good maps of New Zealand, and they've always been a go-to of mine to actually look at. They're quite hard to find, but it's worth pursuing if you are wanting sort of to get an appreciation of the soils and geology of New Zealand. So go to the GNS Science sort of QMAP series, but also the old Soil Bureau maps. They're absolutely fantastic, because unlike the geological maps, which are often done out of a Land Rover window with binoculars, the soil maps of New Zealand were actually produced by doing an auger every chain. So every 22 meters, you actually had an auger hole in the ground over New Zealand to actually develop these soil maps, which are absolutely brilliant. But they're often not used.
On that, and a question just from me is that, what about the data that we're getting from the geotechnical database? Could we be using that sort of thing to be producing good quality maps?
Yeah, now that I think holds out a lot of hope, and I'd implore everybody who is basically doing any investigation work in New Zealand to make sure that you actually put that data onto the NZGD. It's a fantastic tool for New Zealand, and open source information is the way of the future. And so with RetroLens, which basically gives you access to all the aerial photography going back to the tiger moths in the 1940s when we started to do it, and now with the NZGD, it's just a fantastic repository of stuff which can then be picked up and used for mapping. But there are so many holes all over the place that we need to fill in. So anyone who's doing anything, get your client right at the start to agree that that information will be shared onto the NZGD. And yeah, wonderful, absolutely wonderful. Can't speak highly enough of that that source. And I just hope that government is going to continue to look after that repository and make it readily available to everybody in the future as it is now.
If anybody doesn't know where that is, by the way, if you Google in New Zealand Geotechnical Database or NZGD, then it's the first thing that comes up. And here's a curly one. What needs to be done going forwards to address the issues of structural engineers still not listening to the advice?
I'd like to think that Engineering New Zealand can be more of an enforcer, maybe than it has been in the past. Because it's quite clear that the qualifications that are submitted by ENZ are absolutely relied upon by local authorities, and in some cases it's merely a case of making sure that there's an insurer behind a problem, and so I'm quite cynical about that. But I think we really do need to make sure that if someone is saying they are competent, that they are, because otherwise we still have the issue of local authorities saying, yeah, I see the website and I see that competency, but I don't believe that. And that's not really a good look, because that suggests that people on the ground are suggesting that what people are saying they're competent in to ENZ is not actually right.
And here's one from a student. As a student, what do you think is important to be conscious of coming into the industry?
Geotechnical is good in that I don't see AI actually solving the geotechnical issues around, because it's so grey. It's a complex system which I don't think is ever going to be easily rationalized. So geotechnical is, I think, still a good area to actually come into civil engineering. We often basically try and stop people from doing robotics and other sort of more sexy things, and to come into the geosciences, whether that be through civil engineering or the geosciences or earth sciences. But I think there is still a real need for people who can look at a landscape and understand how that landscape formed, but more particularly the processes that are actually actively occurring and what climate change is going to do to those processes, as well as things like slope modification and others. So I think it's a wonderful area to work in, because it is not easy, and because you keep on learning all the time. So just to plug, I think it's just a great area to come into. But you do need to look at those broader papers such as geomorphology, engineering geology, those sort of things, irrespective of whether your bent is going to be engineering design. I think it's still something which you need to actually do.
And if you look at the number of chartered geotechnical engineers around New Zealand, there's only around about 400 odd last time I checked. And there's big gaps all throughout the country. So there's definitely a job for you, which is always nice.
And I think generally, I mean, engineering, we need engineers. I mean, we were desperate for engineers in New Zealand. You just look at basically some of the large infrastructure projects that are on the books at the moment. I have no idea how we're going to actually resource those projects. And when we look at what's happening across the ditch, I can see a lot of our best and brightest actually heading across to the infrastructure projects in Victoria, New South Wales, and other places, which is a real concern. So I think we do need to get into the schools and try and get people involved in engineering, geosciences, earth sciences, and say that this is a worthwhile career.
And here's a plug for the Wonder Project, by the way. You should definitely be signing up for that as a member of Engineering New Zealand. I do it. It's good fun. So here's another question. Do we have a zoning of various unstable landforms for New Zealand based on some risk ratings?
We do, and what I say is we do. Some local authorities do, and it's a real mishmash. And I guess that's where the Waikato, Rotorua sort of lakes councils getting together, because I think there are now 12, not just 8, to get some sort of commonality of approach. And it'd be nice to think there was New Zealand wide, that you could actually join that up from 8 to 12 to encompass all the local authorities, what are there, 80 or something. But that's not going to happen. But some councils have got pretty good systems. Obviously Whangarei has got that. If you go onto their website, you'll see risk ratings there. And the good thing about that site is it's not saying you can't do anything anywhere, but it says, if you want to try and develop an area that's looking pretty dodgy, you need to do a lot of investigation, and it sets out some of those requirements. And I think that's actually a start, because the council guy behind the desk, when someone comes in and says, I don't need to do anything, they can say, yes, this is actually what you need to do, because this is now prescribed as something which is mandated by council. But yeah, it's variable throughout New Zealand. But I think the Waikato Building Consent Group, I think, is really onto something. And as I say, if you go onto the Collab Solutions website, it's inspiring. It's something which I think is, a model for where we need to head.
Next question was, looking at the geomorphology of the area, was there any indication of previous slips in the Abbottsford area apart from the one mentioned on adjacent land?
No. That was the stunner, but I mean, it wasn't just in the near vicinity, it was actually right alongside and became incorporated within the wider slip. So it should have been, I guess, staring at everybody, but most people missed it. And so when they're trying to think, well, would this thing actually accelerate and turn into total custard, they should have looked at that and been a lot more concerned earlier than they were, because that was an example. It's a bit like the West Taihape landslide, in that there are other sorts of landslides like that in the area, although not immediately alongside. But that's another example where, not only did it have 206 houses, but until fairly recently, it had a primary school actually sitting on it. And our Oricon and ourselves actually were involved in deciding to that it wasn't appropriate to have a primary school actually sitting down the toe of this very large, albeit slow-moving landslide in Taihape, and that was actually relocated to a safe site.
Now, next question would be, has New Zealand got a situation of analysing core samples, geological layers that contain a thin layer of Montmor deposited volcanic ash that causes sudden slip when saturated? And has there been any study and found examples of this situation?
Yes, if you look at Amakara, I think that's probably an example where you've got these thin, almost quick clays, tongue tie, which it was interesting actually sampling some of these materials at the base of the exposures in Amakara, that these were quite stiff to hard, but when you press them with your hand, they would between your finger and thumb, they'd eventually just collapse and squirt out. And that was the closest thing that I've seen to a quick clay in New Zealand. But we do have a lot of bedding where we have montmorillonite or smectite rich clays. So the Amakara example was the Tauranga beds, but obviously you get it within the tertiary sedimentary rocks as well. And the interesting thing, I guess, we see there is that these sort of block slides, these low angle failures, we haven't seen a lot of them recently, but in 2008 in Auckland, due to prolonged rainfall, we had sort of 9 months of rain, basically. We then saw these large landslides undergo movement again, which we hadn't seen for 40 years. So it's quite interesting as we head into maybe in some areas a lot of a wetter regime, not quite a pluvial, but a much wetter future. Are we going to be seeing a lot more of these? My guess is yes, because they're in the landscape, and just because they haven't moved, we now realize that why they haven't moved is we haven't had the prolonged rainfall. We had the high intensity rainfall, which causes the shallow failures, but we haven't seen these big failures move due to much higher groundwater levels, which takes often months, possibly sometimes years to actually develop. So yeah, I think we're in for an interesting time.
And I'm scrolling through the questions a little bit. We're going to have to get you to answer some of these afterwards and write the answers down if that's okay, Nick.
Yeah, really happy.
The one from BC Perry, how do you suggest we get local councils to take geotechnical investigations seriously? At the end of the day, they set the bar of what is acceptable. I'll just chip in a little bit first here. And it's actually a really good question because my role as the engineering practice manager here is what does good look like, you know, and how do we define what that is? Not necessarily best practice, but what is good practice, you know? Getting everybody to accept to agree on best practices is almost impossible. Good practice is hard enough. And so we worked with the Geotechnical Society and the Engineering General Practitioners Group last year and put out a template of things that should be in an initial geotechnical assessment report. I can't remember if that's been advertised yet, but if you go onto the practice notes and guidelines page of Engineering New Zealand, it's about 2/3 of the way down with the flow chart that we mentioned earlier. And so that sets the you know, the base for what should be provided by a structural engineer when they're doing an initial assessment. And what we're about to start doing is working on with the Geotechnical Society once again, as well as the Structural Engineer Society, some input from some BCAs as well around what a good quality geotechnical report looks like, and the types of information that should be contained within that. So from my point of view, that's what we are doing here from Engineering New Zealand, as well as the Geotechnical Societies, of course. Nick, over to you for your thoughts.
Yeah, I think that's an interesting comment. And I guess the real problem is that we do have a lot of places in New Zealand where the income levels are pretty low. We have a lot of socially deprived areas, particularly in Northland and East Coast, where the idea of the cost of a geotechnical investigation just seems to be out of reach. And the problem is that councils therefore are more I guess, pressured to accept perhaps something which isn't quite adequate. But councils themselves have a duty of care that's beyond that. They should be actually looking at the hazards themselves, independent of the private sector. They should firstly be producing hazard maps. And I guess the real problem is a lot of those councils aren't doing that. They're basically pushing that liability directly onto the structural engineers and the geoprofessionals working in that particular area. And it's hard, you know, I do appreciate how hard that is, but I think we need to put more pressure on councils through LGNZ. And, you know, Stuart Crosby, we worked with him when he was the mayor of Tauranga with the Tauranga landslides in 2005, and he was absolutely fantastic. So he actually gets natural disaster risk and natural disaster risk reduction and what councils should be doing. So I think, you know, that's an avenue, but also I guess through the Minister of Local Government currently in Nana Mahuta, I think we need to actually have some good conversations with the politicians as well as the heads of LGNZ to actually make sure that local authorities themselves are doing their part on behalf of their communities, and they aren't just letting the market, if you like, just potentially run amok with deciding what is appropriate, or as Martin says, what does good look like?
You know, in the next couple of weeks, I'm actually having a meeting with a group of engineers and a BCA down on Kapiti Coast, and it's been really good, because they're both groups really want to collaborate and work together to produce something that's suitable for everybody. And when you can get those communications going, then it really helps. And feel free to contact me. If there's any way that I can help you with a BCA, because typically they want to be working together with everybody as well. It's better for everybody. Can you please elaborate on the definition of medium risk?
Medium risk, yes, it's that old catch-all, isn't it? Like the middle child. It's sort of, it's not bad and it's not good. It's somewhere in between. And I guess it's try and get that grey, and we tend to put lines on stuff, and because it's impossible to put a line between a low and a high, it's basically the band that's in between. So it's a bit like the zoning in Canterbury that occurred after the earthquakes. We went into green and red, and we had a lot of orange, but eventually we did manage to put the orange into either green or red. So I think with time, you should be able to have actually something which is, a place you can go and a place you can't go. And I think that's where we're heading. But yeah, medium, it's a bit of a cop-out.
Yeah, it makes things harder for everybody, really. But on that, look, thank you, everybody. I really appreciate your time. And, as Nick was saying at the beginning, Bernadette for making all of this happen in the background there at Engineering New Zealand, and Nick, of course, for coming on and sharing your knowledge and time, and the time that you'll take for answering all the questions and so on in the future as well. Much appreciated. Thank you.
Absolute pleasure. Thank you, Martin. Thank you, everyone.